All right, so today we start chapter 6. For the problem of the day, I actually want you to fill it in from the packet. Assignment number 1, there's a chart here, and pretty much what we're going to look at is roots and what are perfect squares, perfect cubes, or perfect fourth powers. Right now you've only learned perfect squares. So I'll start the first one with you here. So for instance, 1 squared is what, 1? And 1 cubed is 1, right? 1 and the fourth is 1. Let's try 2 as well. 2 squared is 4. And honestly, you're going to want to use a calculator for this to make it go by a lot faster. 2 cubed, 2 times 2 times 2 is 8. Then 2 to the fourth is 16. And so on and so forth. Right now, you only know about perfect squares, but this chapter we're going to take a look at other perfect powers. So pause the video and fill this out, please. And here's all the answers that I have here. Make sure you fill this in. This chart's going to help us to determine some of the problems that we do today, especially when we're taking a cube root or fourth root or something like that. So make sure you have this all filled in. So 6.1 is evaluate nth roots and use rational exponents. So right now you've only ever heard of a square root. There are other roots out there, and that chart's going to help us to set some of them up. So start by saying nth root of any number a. See how there's a little n out here? Now when it's a square root, 2 is understood, but any other thing besides a square has to be written here. If we take the root, we could also write it as an exponent as a fraction. Now n is the index, we call it, the index of the radical. So this would be the square root of a, which can be written as a to the 1/2. Make sure you write that down. Cube root of a is a to the 1/3. Fourth root of a, a to the 1/4. Fifth root of a, a to the 1/5. So you get the idea here. To explain the index a little bit better, the index is how many times you need the same number. How many times you need the same number. So if I take, for instance, if we go back for a second, what if I told you, what's the cube root of 8? That would be what? 8 with the cube root, which is the same as 8 to the 1/3 power. Well, here's my perfect cube. Find it. Cube root is this column. So here's 8. If I go all the way to the left, cube root of 8 is 2. Did you guys see how we use the chart to determine that? What if I gave you the fourth root of 16? Fourth root is here. Here's 16. Go over. Fourth root is 2. All right, so that's what the chart is used for, to help you in a couple assignments, setting everything up. So what I want you to do, with that being said, complete problems 1 to 10 on assignment 1. I'm not going to go over them right now. In class tomorrow, we will actually go over everything, make sure everything's all right. It's just a little warm up to what you're going to be working on. So the next thing we'll talk about is rational exponents. Rational exponents are fractions. And I write split fractions to get a root times a number. So if I am telling you 16 to the 3/4, this number, the 3, is your power. Then the 4 is your root. So how we would write this is I split it up, I keep 16, I keep the denominator inside, so it's the 1/4 power. And then the numerator, which is the power, goes right outside. So once again, I take the power that comes out front. The root is just 1 over whatever the root is. Now, don't forget, 16 to the 1/4 is the 16th root of 4, right? Write it like this. So what you need to do is you go back to your chart. I'm going to go back for a second. If you go back to the chart, 16, the 4th root of 16. Here's 16, perfect 4th. It's 2, right? So that now becomes 2 to the 3rd, which 2 cubed, 2 times 2 times 2, is now 8. So this is how you evaluate rational exponents of fractions. Now, we just did that in this setup here, a to the m over n power, a to the 1/n to the m, that's the step here, or these two match up here. So this is the same as this. This is the same as this before I evaluate it. Now what happens if it's a negative fraction? Negative, if you remember from before, it flips the denominator. The same thing follows suit. This is the same here in the denominator. This is the same here in the denominator. So now let's take a look at some practice problems here. We write the expression using rational exponent notation. Okay, so we are changing our roots to fractions. Now when you have a root and there's no number, we always understand it to be a 2. Square root is always understood, whereas other roots we have to actually write there. So I would just say this is 121, the 1/2 power. That's my answer. Now, how we write the next one? The root is the number in the denominator. The power is the number in the numerator. So that's 11 to the 4/5. And that's how I would rewrite that one. In example 2, we're doing the opposite. We're going from like this answer and going back. So we write the expression using radical notation. Radical notation is those roots. So 1/4 would be the 4th root, like so. And then this one, the 5, the denominator once again, goes with the root. So a big parenthesis, and the 2 goes out here. Right. So you want to be comfortable going back from rational exponent notation and radical notation. Now, example 3 says evaluate using the properties. All right, we're going to actually solve just like we did on a slide or 2 slides ago where we solved that 16 to the 3/4. We're going to take a look at solving these using our properties. Usually I like to change it to the fraction root. So 1/25 to the 1/3 power, or the cube root of 125, use your chart. Go down the cube pattern once. You should get a 5. And always keep parentheses in case something's a negative. That does actually matter if it's negative or positive inside the root. 5 squared is now 25. And now 8 to the negative 3/4. Don't forget what you do with a negative fraction, or an exponent I should say, is move it, flip it, goes down to the denominator. Let's rewrite this. The cube goes out here, so it's the cube root of 8 to the 4th. Now for these, I want you to write out all the different steps because I don't want you just to solve it. It's important to know how to do it by hand. we're going to want to see work. Cube root of 8 is 2. So I evaluated the root. To get 1 over 2 to the 4th, it's 1 over 16. And that's my answer. Now, if we look at the next part, important calculator keystrokes. Some of them will not give us nice answers like 25 or 1/16. So I want you to be well-rounded in solving them by hand and also solving them via calculator. Here's the square root button, cube root button, any power, and any root to the x power. Make sure whatever calculator you are using, bring it in tomorrow in the next class, because you're going to have to, I'm going to look at yours individually and make sure that you know how to type these into a calculator. So it's very, very important. Every calculator is different. So make sure you bring one in tomorrow that you can solve these as well. So yes, there are problems where I want you to evaluate the expression and round. It says evaluate the expression using a calculator, round the result to 2 decimal places when appropriate. All right, so even on your next quiz or test, you're going to do some by hand, showing all the work, and you're going to do some by using a calculator. So first one, I'm actually going to type this, I think. First we get 2.17. Next one I get 19.35. Last one I get 1.72. I know it sounds very obvious, like, oh, I know how to type in a calculator, but please make sure you could get these. And then if you can't figure out how to get my solutions, you ask me tomorrow. Every calculator is different. I'd hate to see you get problems wrong on a test or quiz because you didn't know how to type them in correctly. All right, now determine the number of real nth roots when solving. This is important because the last slide is going to deal with, slide or two is going to deal with solving for a variable. It matters if n is even or odd. Now even actually reminds you of a square root, right? If my number was less than 0, we had no real nth roots. Do you remember a problem like, for instance, let me write it out. What does this mean? So what if I gave you square root of negative 4, right? Didn't I get plus minus 2i? So a was less than 0, right? A was negative 4. There were no real nth roots. So square root fits this. Any other even root, as in 4 or 8 or 100, will fit it too. A equals 0, there's one real nth root, which is 0. So once again, I'll apply it to what we know with square roots. Square root of 0 is just 0. There's no plus minus because 0 is nothing, right? It's not positive, it's not negative. And if a is greater than 0, there's 2 real nth roots. So the example I can give you, square root of 4 equals plus minus 2. So you have 2 real, 1 real, 2 imaginary. Or no real, because this is imaginary, right? Now, this one, like I said, even is the square root. It's any other even root it applies to. So you already have seen that with square roots before. What if your root is odd, like a cube root or a fifth root or some odd number? When a is less than 0, there's 1 real nth root. When a is equal to 0, lo and behold, there's 1 real nth root. And when a is greater than 0, there's once again 1 real nth root. So odd is easy in the fact that there's always one single answer. You don't have to worry about real or imaginary numbers. They're all real. There's only one of them. There's no more plus or minus for these. All right, so the next example, I want us to solve algebraically and solve for x. Take a look at this one here. All right, so here's how we solve the last group. Okay, I have x cubed equals negative 125, right? And just to reiterate here, solve the equation, round the result to 2 decimal places when appropriate. Right, x cubed equals negative 125. The opposite of a cube is a cube root. So you take the cube root to both sides. And if you go back to your chart, the perfect cube of 125 is 5. Now cube roots See how there's a negative inside the root? It's an odd root. It's not like an even where it's a plus minus I. Your final answer is just -5. That's it. So one single root like we saw on the previous chart, right? So if the number is negative, a is less than 0, one real nth root. Okay. B, we always want to divide and get like the number away from it before we take care of a root. X cubed equals 64. So you always want to isolate the exponent and the variable by itself first. Just like we did with square roots. The only difference now is there's multiple roots in this chapter as opposed to chapter 4. Take the cube root of both sides. X equals 4. Once again, it's an odd root, so you do not do plus minus. It's just one single answer. If it's positive, it stays positive. So 64 was positive. Here, -125 was negative. Negative before you take the root, still negative. Now C, be careful. Do not multiply. Do not distribute the fourth power to everything. That's the same as saying 4 of these x minus 3's. We don't want to do that. You're not going to be able to solve it. It's going to be this huge problem. You simply want to, for this, take the fourth root of both sides. On the left, you'll be with x minus 3 equals fourth root of 21. Be careful. We're going to have to round on this one. This is not a perfect fourth. Round to 2 decimal places. Fourth root is 2.14. But you see what I did here? It's a plus minus. Even roots. When it's positive, here's when it's positive. Do you see how it's 2 real nth roots? Do you see the plus minus? It applies to any other even power as well. Now I bring the -3 in front. The plus minus is a positive. And there's 2 solutions here. You're going to want to solve them each. We did this with square roots, so it's only right we apply it to any other even root. 3 plus 2.14 and 3 minus 2.14. So we actually have to evaluate them. First one, 3 plus 2.14 is 5.14. And 3 minus 2.14 is 0.86. All right. Last one here, D, very similar to C, but you see how what the parentheses squared is not isolated yet, like in C. The -4 and a 2, we want to get rid of the -4 first. Bring the -4 to the rise of +4, which is 1 whole 4 then, right? So we're going to want to divide both sides by 2. -52. Take the square root to get rid of it. Once again, we do not want to FOIL and multiply this out with 2 parentheses. You're not going to be able to solve it nicely. Once again, it's an even root, so we need that plus minus 7.21. -8 comes over as a +8. Remember, you have to evaluate both of these, just like we did here with the plus in one minus another. I'm just going to go to the final answer. Make sure you can get this. We get 15.21 and 0.79. As our answers. And that's it for 6.1. Homework's going to be easy for you, so please make sure you do it. You're just doing assignment 1, numbers 1 to 10. Assignment 2 is what we'll be doing in class tomorrow, where I want to make sure you have enough time to go through it and ask me questions.